Welcome to Lesson 2 from our first physics unit. This lesson will focus on acceleration. In front of you right now you should have your Lesson 2 acceleration worksheet. You should already have completed Lesson 1, and when you're finished with this worksheet you will start with the concept map. Keep in mind most of this worksheet is just some acceleration calculations and some example problems that we are going to be doing together. Alright, we're going to start with Roman numeral number 1, acceleration. It says when the velocity, your first blank is velocity, of an object changes, we call that acceleration. So it's basically when something starts to move faster or slower. It's not moving at constant speed. Imagine you are at a red light. When the light changes and someone steps on the gas, you feel the car speed up, and this is called acceleration. So it literally feels like the chair is kind of pushing you forward, and you can feel yourself speeding up with the car. That's called acceleration. Now for letter B, it says speeding up and slowing down. Usually we think about acceleration as when we're speeding up, but objects have acceleration not only when they're speeding up, but when they slow down as well. So think about when you hit the brakes, that's also an acceleration. But when a car slows down, it has a negative acceleration. So we're going to get rid of that, get rid of this, and we're going to look at a picture that kind of shows what's happening here. So this picture is going to kind of show us two different types of acceleration. If you look at the picture on the left, and this goes with letter C, it says that positive acceleration is when acceleration is in the same direction as the velocity. So what happens is the car is moving that way, the velocity is that way, it's increasing that way, so it's a positive acceleration. Now letter D says negative acceleration is when acceleration is in the opposite direction of velocity. So if you look here, the car is moving this way, but the acceleration is going back that way, so it's slowing down. So that's where we get that negative acceleration from. And our very last point is that not only is a change in velocity change in acceleration, but a change in direction is also a change in acceleration. Now we're going to talk about calculating acceleration, and I'm going to give you some formulas. So first it says acceleration is the change in velocity over time. And we're going to write the formula for this below. So we're going to write acceleration, so you should write this underneath letter A, and that equals the change in velocity, we write change with a triangle, v, over the time. So it's the change in velocity over the time. Remember, this triangle equals change, and this t equals time. Okay? So let's letter A. So you can pause a second and write that down. That all goes with A. So we'll move that over here a little bit. Okay? Next, letter B. It says to take a change in velocity, you take the final velocity minus the initial velocity. So that's how we get that delta v that we saw on top. So what I want you to write under b is I want you to write vf, and that stands for final, minus vi, and that stands for initial. Okay, and that's all for letter B, so you can pause and write that if you need to. So that'll go up here with B. Now, letter C, we need to write the relationship between acceleration, velocity, and time. Now this is the actual formula we're going to use. We're going to have A, that stands for acceleration, equals VF minus VI. And we're going to divide that by the time that it takes. So that's what you should write for letter C. So again, you can pause, write that out. Lastly, D, the unit for acceleration is meters per second squared. And how you write that is m over s squared. So that's our units for acceleration. Alright, so now we're going to do some example problems together. And so I have our formula in here that we're going to use for all of them. So this A equals VF minus VI over T. And I'm going to show you what each part of this is. What we're always trying to find is this average acceleration. So where it says average acceleration here, that's letter A. Okay, so let's read it. It says a soccer ball slows down from 30.6 meters per second to 11 meters per second west during a 2.75 second period. So I want to know what is its acceleration. So what I can do is I know that this 2.75 here, this is my t, okay? This 30.6 is my v final, and this 11 is my v initial. So what I need to do is I need to plug those numbers in. So I'm going to have A equals 30.6 minus 11, and that's meters per second for both of these. And we're going to divide it by 2.75 seconds. Okay, so then all we do is we plug these numbers into our calculator. So if you have a calculator out right now, you can follow along with me. So we plug these in, and our answer for acceleration is minus 7.13 meters per second squared. And we would put a box around that. Okay? Alright, so once again, we have another example problem here. So we're going to use our same formula. Here we're going to have A, acceleration equals, I'm going to do a different color for each part, V final minus V initial divided by, and it's our time. So I'm going to circle these so we can kind of start to see where these parts are coming from. Okay? So maybe I'll write this acceleration in black so that doesn't confuse us. So we'll have the acceleration's black. So we're going to find the other parts in the equation here. Okay? So it says a car starts from a stoplight and is traveling with a velocity of 10 meters a second east in 20 seconds. So here our V final is going to be this 10 seconds. Okay? So when we write this out, we'll have A equals 10 meters per second. Okay, minus our V initial. It was stopped initially, so our initial is 0 meters per second. And we're going to divide that by the time that it took. So it took 20 seconds. Okay? So where the time is right here. So I'll show you that in blue. And where our V initial is it starts from a stoplight, so that means that it wasn't moving, so it's 0. That's where we're getting the 0 from. Okay? So now all we do is plug it into our calculator, and the answer that we're going to get is 0.5 meters per second squared. So once again, this number is right here. This number is our time, so it goes on bottom. And this number is our V initial, 0. Alright, here we go. Example 3. Example 3 says a ball rolls down a ramp for 15 seconds. If the initial velocity of the ball was 0.8 meters per second and the final velocity was 7 meters per second, what was the acceleration? So what we need to do first is we need to find our individual parts. So it says the initial velocity. So initial velocity is VI is 0.8 meters per second. So right here, this is VI. Okay? So we're going to plug that number in for it. And then it says the final velocity was 7 meters per second. So we know this is VF. And we still need the time then. So we're going to plug these first ones in. So I said the VF right here was 7 meters per second. So I'm going to write 7 meters per second. I'm going to subtract that from the VI. So my VI is right here. So I'm going to write 0.8 meters per second. And now I need to divide that by the time, but I need to figure out where the time is. In the first part it says a ball rolls down a ramp for 15 seconds. So my time here then is 15 seconds. If I do this out on a calculator, the answer I get is 0.413 meters per second squared. Alright, our very last problem is talking about a meteoroid. So it says a meteoroid changed velocity from 1.0 kilometers per second to 1.8 kilometers per second in 0.03 seconds. What is the acceleration of the meteoroid? So I'm going to have A equals, and then I need to find my variables here. So if I'm looking at the problem, I know that this 0.03 seconds, that must be time. It's in seconds. So I can write out over 0.03 seconds to start, because time always goes on the bottom. Then, if I look, it says that the meteoroid changed velocity from 1.0 to 1.8. So 1.0 was my initial or starting, and 1.8 was my final. So what I'm going to do is I'm going to write 1.8 km/s minus 1.0 km over s. Okay, once I'm this far, all I have to do is plug these numbers into my calculator. So you can try that now. My final answer is going to be 26.67 kilometers per second squared. And that is going to wrap up lesson 2. Now that you're done with lesson 2, you can start your concept map.